All right, guys, welcome. Sorry I couldn't be with you today, but we're going to take a look at lesson 22, the side angle side congruence. And so the opening exercise just asks, is it possible to know whether there's a rigid motion that takes one triangle onto another? And so the answer here is going to be yes. Remember, we can just describe this in words. Okay, so yes, we can describe in words. We should probably say the transformation, what it is we're describing. All right. So the discussion. All right. It is right. So it's true. We don't need to actually show the rigid motion. We just need to be able to know there is one and apply it and describe it. So we're going to talk about the side angle side, specifically that congruency theorem today. So if we were just to describe why these triangles are congruent, given that AB is congruent to A prime B prime, angle A is congruent to angle A prime, and side AC is congruent to side A prime C prime. How would we go about showing this, right? And think about how would you get this triangle to move on top of that triangle, right? And so what you might say is like, it, there's a couple ways to get this to happen, right? Depending on how you want to do it. But the way the book tells it about it is kind of the easiest way that I think I would describe it, which is if I took this triangle, okay, and we'll see the moves on the next page as we go across here, all right? If I were to just take this triangle, I would want to slide this triangle over to have one of the angles or one of the points overlap. And then I would want to rotate this triangle, okay, so that these two sides here overlapped. So it would look something like, if that was our triangle in red, now our triangle is going to look something like this, right? And then we just have to flip this over that side, and now they'll be mapped onto each other. So we're going to go ahead and do that. We're going to describe those moves on the next few pages. You actually don't need to make all those things go away. They're kind of cool. So, all right. So on the next page, we can define our congruence by finding the composition of rigid motions that maps one triangle onto the other. In this case, we're specifically going to map A prime, B prime, C prime onto ABC. So which 2 points determine the appropriate vector, right? Any two corresponding points can be used, okay? Any two corresponding points. All right. In our case, specifically, it's ray A prime A with the arrow over the A because that's the way we're going. So the vector we're using, right, is A prime A. You can just put that in the blocks there. So, all right. So yes, and then we could just put that down for ourselves. Okay. All right, let's describe that transformation in words here. Okay. So we would say translate, right? What are we translating? Okay. Triangle A prime, B prime, C prime along ray A prime A. And then how far? When do we stop? Do we keep going, right? We always finish with that until it maps onto. Okay. Now, what is it mapping onto? Okay. And what's it, right? Until this, right? And so we want to get specific. So here, instead of saying it, right, what do we actually want to map onto what here? Okay. So we actually want to say until A prime, because that's the actual, we're translating the whole triangle, but we're going to stop when this point goes onto that point, not when the triangles overlap, because they're not going to, right? This one's not facing the same way. So until A prime maps onto A. So it's a little different when they're not perfectly going to overlap if you move it. Now the book wants you to use this notation, but the Regents exam doesn't. So we're not going to worry about the notation part of it, okay? But for right now, all we want to know is we started with triangle A prime, B prime, C prime, right? And we're getting this triangle, okay? Which is A B double prime, C double prime. Okay, that's our new triangle now. So now that we're here, okay, we've moved the triangle to here. Now what do we want to do? So now the book says we want to use a rotation. Okay, there's my angle of rotation. They said it's CAC prime, double prime to bring this onto itself. And they're calling it either a clockwise or a counterclockwise. It doesn't matter which way you spin, you'll eventually get there. So let's describe this transformation in words. Okay, so now that we're here, we're going to rotate this triangle. We want this to happen where this is going to overlap and fit right on here. And so this point is going to become B triple prime when we get there. Okay, but remember what's actually going to overlap. This side is going to touch that side, right? Okay, so let's do it. We're going to say rotate triangle. What triangle do we have? A, B double prime, C double prime. Okay, what direction? So we can say clockwise or counterclockwise. We'll go, for us, it seems easier to turn this way to the right. So we'll say clockwise. I know I started writing counter, so I apologize for that. CL. And if you did already, right? Whoa, we made stuff disappear. Get back here. B prime. And we could say, actually, we normally were writing around A clockwise. Okay, we're not going to use the angle. We're going to finish off with our saying, right? So what? What do we want to have happen again? Remember, we want to have this side, A, C double prime, maps onto what side? A, C. Okay, so this segment maps onto that segment. Okay, let's take a look at the next page. So now the rotation maps our appropriate side length onto each other. Now remember we talked about that being B triple prime. So the last thing we're going to need to do, okay, is take this and just reflect it over that line and have that map onto it. Okay, so let's go ahead and let's describe this one in words. So we're going to say reflect triangle. What's our triangle we have now? A, B triple prime, C, over, what are we reflecting? Right, over what line? A, C, and what do we normally end with? So it maps onto, okay, triangle A, B, C, and we're done. Okay, so the other way to do this, now there's another option here that we could have done, right? At this point, there's one move we could have made. Okay, if we had taken a compass and we had drawn the angle bisector right along this line, so it cuts this angle in half, or you can think about it also being like the perpendicular bisector of CC prime. Okay, so if this is the perpendicular bisector of CC prime, we could also just reflect this figure over that line. Okay, so that's another option. So we could have just done a translation and then a reflection over the perpendicular bisector or the angle bisector. Okay, but those are the three moves. So remember what we did, right? For f, for the first function, we did a translation, right? Then we did a rotation, okay? And then we did a reflection. Now they want you to write that in like this, the function notation, but we're not going to worry about that right now, okay? We want to be able to write it in words. Okay. So let's take a look at our first diagram. Remember, if we're doing mapping onto each other using the side angle side or whatever congruency theorem we give us, if we see the shared side like this, what transformation do we need to get this triangle to map onto that one? Right? Good. A reflection. Okay. We would say over line AC. Okay. If there's a shared vertex, right? Normally we're going to do it in two moves. We're going to do a rotation, okay, around A, And then the second thing we're going to do is the not translation, reflection. Apologies. Okay, over line AC again. Now there's another option where you could do a reflection over the perpendicular bisector of, right, C double prime, okay? Or you could say over the angle bisector of CA C double prime, your choice. So those are the two options, okay? All right, so let's take a look at the first exercise here. Given the pair of corresponding sides equal in length, pair of included angles, okay, of equal measure. So included means that if my two sides are given as equal here, okay, the included angle is always the angle that connects these two sides together. So it's got to make, right, that angle. These two sides create the angle. Sketch and label the three phases of the sequence of rigid motion that prove the two triangles are congruent. So step one, we're going to do the translation. All right, so we're going to have, right, this triangle here, okay, mark it down for ourselves. And then we're going to have this triangle come down and meet up with it. So what points do you want to meet together here? I guess is a question. And actually, probably for my purposes, should have drawn this a little bit higher up on the side there. All right, so I'm going to have, I think, these two angles right here meet. So I'm going to make a shape, grab a ray, we're going to go like that. We have these two angles meet up right there. Okay, so I'll draw this one in blue. So we're going to have this one is going to be like this. I'm just looking at that drawing over there, kind of eyeing that out here. All right. There's the translation. Okay. Then we're going to do our rotation. So we still have our first triangle. Okay. And now we're going to rotate our second triangle. So this side's going to match up. So this side's going to pretty much be a straight line down. So coming over. This side's congruent. Okay. And then the last one is going to be the reflection. And you only have to draw one triangle here, right? Because it's going to be the exact same triangle. Okay? That's it. That's what that looks like when we're done. Okay. So all we're going to do now is we're going to kind of get away from that. And I want you to focus on what we talked about the other day. So that's how we describe our transformations. We'll continue to do that a little bit throughout the unit. Okay. Today we're just going to know whether or not we can show these triangles are congruent. And remember, we're going to be using the SAS congruency theorem. So if you look at two triangles, right, or a triangle, we have two sides and the angle that's in between them. Okay. If you pick the angle that's outside over here, this is going to not be side angle side. This is going to be side, side, and then the angle. This is the donkey theorem. It's got to be the one that's included in order for this to work. Okay? So remember your question. Remember your proof here. All right? Let's see if we can do this, and we'll kind of do it in a little proof version in a second here. So given that angle LMN is equal to angle LMO, and that's marked right here, okay? And MN is congruent to NO, do the triangles meet the side angle side criteria? So if we go ahead and draw our T-chart. Now we're going to skip step one because it's right here and we're going to save some time. So we're going to go right to step two. What else do we need to know in order to do side angle side, right? What else can we say is congruent? So there's no keywords. We talked about that yesterday. But if we look at the diagram, right, these two triangles, right, what do they have in common? What are they sharing, right? They're sharing that side in the middle. That's that reflection step we talked about yesterday. So we can say that Ln is congruent to Ln, right? This is the reflexive property. And then now we can say that these two triangles are congruent. So triangle LNM is congruent to triangle LNO. I just used the label that was right there. right? And then we're going to write SAS congruent to SAS. Now, if it was no, right, we would just write not enough information, okay? Now, it also says describe the rigid motions that would map one triangle onto the other. So all we would have to say here is what? Reflect, okay? Triangle, pick one. We'll do the one on the left. L, N, M over line LN, okay, line segment LN. So it maps onto triangle LNO. Okay, that's it. All right, let's try this one. So take a look. What do you think? Do we have enough information? Let's do the cheat chart. We're going to start with step 2, right? Step 1's the givens. We're going to skip that part. Okay. So do we have enough information? Oh, hopefully you noticed. Right now we have angle, side, angle, but we want side, angle, side. So we do have enough if we do this side right here, right? So IG is congruent to IG. Okay. Once again, that's reflexive. Property. That's a little bit sloppy. Let's go back and fix that. Lexive. Okay, and then do we have enough to say the triangles are congruent now? We do. So triangle HGI is congruent to triangle GI or JIG, and that's side angle side, congruent to side angle side. All right. Now, how do we get this one to map onto that one, right? So the couple things you can do here, right? Okay, so because these two sides are congruent, we could spin it and have it map onto itself. So we may have to spin it over a certain point if we know what point it is. Okay, or we could just rotate it around, let's say like point H. Okay, let's say we rotated it 90 degrees, right? So it's like this. Okay, then all we have to do is slide from there to there, well, to J, right? And we'd have it mapped onto each other. So that's what we could do. So we could say rotate triangle GHI. Think about how we want to rotate it. We want to start here and end there. So that's 180 degrees. 180 degrees around point H. Okay. Then translate. Okay. Triangle GHI. Now, since we didn't draw a new shape and label it, after we rotate it, it's still that triangle. It's still that same triangle. Now we're just going to slide it. So we're just referring to the triangle we moved. So we don't have to name it again here. Okay. Or do the primes on it. Unless the drawing was done for us and it had letters, then you should. Okay. Along what ray? So H to J. Okay. HJ. And then remember, so it maps onto, and then remember, keep that order. So G is going to go on the I. Okay. H is going to go on the J. Because remember, I changed the order of letters here, right? And then, let's see the other letter. I, right, is going to go on the G. You can see from the order. If we said G, right, it has to be I. Okay. So if we say I, it's got to be J. G's got to be I. H has got to be G. So just make sure it sticks in that order. Okay. All right. And then could we also prove the triangles are congruent given that these two sides and these two sides? Why or why not? Well, let's redraw this. So if we started with this figure going down, okay, we had G, J, H, and I. We have these two. Okay, so now if angle JIG, so this angle here, right, and HGI, this angle here, and HG congruent to IJ. Okay, could we have done it this way? Sure. right? For the same reason, right? So we could say that IG, you could say yes, yes, IG is congruent to IG, okay, by the reflexive property. And then the triangles are congruent by SAS. Okay, that's enough to say. All right, this is the problem set. So this is kind of what you guys are going to do for homework. So just, do they meet the side angle side criteria? And then if they do, describe their rigid motion. So now this one's a little bit tougher because it's got the arrows on it. So remember, those are parallel lines. Remember, our favorite letter to go see is the Z. So if you can make a Z here, right, then we know that these two angles are going to be equal, okay? And then we have the line down the middle. So do we have enough, right? We would say yes, okay? All right, cool. And then what I want you guys to do is just name the things that you're saying are congruent. So we're going to say angle ABD is congruent to angle BDC, and then just write down DB or BD is congruent to BD. So if you label anything congruent, just write it down here, okay? And then yes, and then go ahead and write your statement here for me, okay? So what would be the rigid motion you would use, or motions? Maybe you want more than one, okay? All right, so go ahead and do that for these ones, and then we'll talk about, well, let's do number 2. This one's a little bit tough too. So do the two triangles. If angle R is 25, this is 7, 5, and ST is 5. Do we have enough information to do side angle side? Well, all I know is that these two are equal because this triangle is isosceles, right? If this is 25, I don't really know anything else about the other angles here, and I only have one side of 7, so I have like 7, 5, and an angle. I have these two angles. I really don't have enough. So we would say no, and then not enough information. Okay? All right, we'll do one more together. Given that KM and JN bisect each other, so if they bisect each other, that means that they're, keyword, bisect, right? Cutting each other in half. So these two are equal, and those two are equal. So we're going to write down KL is congruent to LM. Okay. JL is congruent to LN. And then is there anything else that's the same? Look at the diagram. Anything else you notice that's the same? We talked about the bow tie angles, right? The vertical angles in the middle make like a bow tie, right? So angle KLJ is congruent to angle, and then MLN, okay? And so we'd say yes, all right? I think that's all we have to say is yes, okay? And then describe that, how do you get this triangle to map onto that one, right? So this one, we would just rotate. So go ahead and write out that rotation. All right, see if you can finish up these ones in the rest of the class here. If you have a little bit of trouble, that's okay. We'll go over these ones. I'm going to make a video. So if you're having a little bit of trouble for tonight, actually what I want you to do is watch the video. That's going to be in your folder, okay, later tonight. It's going to be pause it, so it'll record that you've watched it. And then make sure you're working along in your module book, and we'll go over this together. All right, guys? So check for the video, and I'll talk to you guys on the next one.